Hello everyone. Now we are looking at set. Set is a container that stores unique elements in sorted order. For example, you can see this. This is a set. It has unique elements and they are sorted in order. Also, for adding elements in a set, we use dot insert function. And you can see here we have added the elements in an unsorted manner. First we have added 2, then 1, then 3, and again 1. They are unsorted as well as there are duplicate values. But what set will look like is this: 1, 2, 3, which means however you store the numbers, they will be sorted, and how much times you store the number doesn't matter, it will only store unique values. Now, time complexity for insertion, deletion, and search in set is big of log n, as set uses tree-based storage. Now, traversal for set is a range-based loop where we write for int x of set and we just print it. Now, dot insert function gives adds the values in the set. Dot size function gives us the size of the set. Dot find is used to find a particular element, and what it returns is the iterator of where that particular element is. And dot count is used to find if element is present in the set or not, and its output is boolean 0 or 1. Dot erase is used to remove an element, and dot clear is used to remove all the elements. Now, dot begin is a iterator which points to the first element of the set, and dot end is the operator which is used to point the element one past last element. Means you can see if this is our set which has four elements, 1, 2, 3, and 4, then the storage, or you can say memory location, pass the last element. Like if last element has 4012, so pass the last element is 4016. Now s dot end will point to this location, and s dot begin will point to first location, and s dot r begin, sorry, it may look v but it is r. S dot r begin points to the last memory location, and for accessing first and last element we can just use um, dereferencing operator s dot begin and dereferencing operator s dot r begin. Now this was it for the set. Now let's see multiset. Multiset is exactly same container like set. There is only one key difference, and that is multiset allows duplicate values. So this makes changes in two functions. Now you can see if it would have been our multiset here, so the values would have been 1 comma 1 comma 2 and 3. So this will change two functions, the working of two functions, that are count and erase. Now what the change will count in count will be, instead of giving the availability of the element, like in set, the count will give us the number of occurrences of that particular digit. And as for the erase will, once we call the erase function, it will erase all the occurrences of that number. Like if number 4 is present 5 times, so when we execute erase 4, it will delete all the 5 occurrences of that 4. Now here time complexity is same for insert and search, but for deletion it is big of log n plus m, and here m is occurrences of that digit. Now the declaration of multiset is multiset data type in brackets and then name of the multiset. Now let's go to unordered set. For unordered set, it is also similar to set, but here the key difference is it is not sorted. It is in random manner. And for traversal also, here also we use a range based loop, and time complexity in unordered set are big O of n for insert, find, erase, and count. Now you may see the key difference of time complexities in unordered set and set is due to unordered set uses hash map for the storage and set uses tree based storage. So hash map gives us big O of 1 time complexity, and tree gives us big O of log of n. Now, big of one type of complexity is not guaranteed in worst case in the uh, unordered set, because there can be hash collisions. Also, one key important point is unordered set does not have lower bound and upper bound functions. So that is it for this video. I'll see you in the next video. Oh, wait. We also forgot to show the code implementation. I'll just show you once code implementation and then we can say goodbye. Now let's look at the code. First we'll include the header file required for set. Okay, now we can start implementing set. So first we'll declare an set named s, and we will insert the values in it. So we will insert, let's say, 10. We will insert some values, 15, 10 again, 18, 98, 20, and we have 18 again. Okay, yeah. So now you can see that we have inserted 1 2 3 4 5 6 7 7 values in the set. Sorry, yeah. So you can see that we have inserted 7 values in the set, but here 10 have two duplicates, sorry, one duplicate, and 18 has one duplicate. And this insertion also is not in sorted array. So now we'll just traverse and print the values of the set, and we can see that how it is stored. So we'll just traverse it once and we'll print all the values. Okay, now we can see how the values are stored in the set. Yeah, we are good to go. We can see 10, 15, 18, 20, and 98. We have inserted 7 values, but there are only 5 values because it has excluded the duplicates. And also we have not inserted in sorted manner, but we can see that set is has itself stored in and sorted manner. Now this was one function, insert. Now we'll try to use another functions. Let's say we print the size of the set. First we'll write, yeah, this function s dot size will give us the size of the set. Another function, find. Now let's say we will take a iterator 8 and we will try to find s dot find. Let's say we have to find 18, so we will find 18, then we will print the value it is referring to. So the output should be 18. And next function is count. Now we'll just check cout s dot. We'll just check if 98 exists in the set, and yes. First we'll look at these three functions. Okay, here you can see the size of the set is 5 because there are 5 elements. Then the iterator is pointing to 18, which means we have found out that 18 is present in the set, and we have found the iterator pointing to it. Also we can see that s dot count of 98 has given us 1, which means true. It means that 98 is present. What if we do 88? So the output should be 0. And yeah, here you can see output 0. Now we will try to use another two functions. We'll just comment this part, and we will first will erase one element. That is, let's say we will erase 98 from the set, and we will try to see if it has. Okay, and after that we will use clear for clearing all the elements, and then we will use empty function to check if it is empty. Okay, the size will tell us if it is empty or not anyways. So yeah, here you can see after erasing 98 we have printed the set, and you can see there is no 98. And after executing clear we can see that size of the set is 0, which means all the elements have been cleared. Now we'll just try to use iterators once. We'll clear this, and let's say we take a iterator first is equals to s dot begin, that is the first element, and another iterator last to the last. Now we'll just try to print the values. Okay, it should give us the first and last values. They are 10 and 98. So yeah, you get the value 10 and 98. So that is it for the set. Now we'll look at multiset. Also remember that for multiset we use the same header file as set. Now we'll just comment this out. Here we'll declare a multiset, let's say named ms. Now in multiset everything is same. I'll just show you the main key difference, that is storing the duplicate values. So I'll just insert 5 3 times, and 4 and 9, 10 and 1. Okay, let's say we have 9 2 times. Now we'll just try to print it once. So it's ms, right? C out x. Yeah, we are good to go. And we will also try to use count and the main key difference functions count and erase. So ms dot count 5. Okay, we'll just run the code once, and here you can see it has 1 4 5 5 5 9 9 and 10, which means it has stored duplicate values in an sorted manner. And also here last 3 gives us the count of the 5. So we can see in set count was giving us if the element was present or not, but here count is giving the number of occurrences of that element. Now we'll just once try to use the erase function. I'll just ms dot erase. We will erase 5, and now you can see that it will erase all the occurrences of 5. And after that if we try to print the count of 5, it should be 0. Okay, here you can see 1 4 5 5 5 9 9 10. Then oh, I forgot the line break, just a minute. Yeah, here you can see 1 4 4 5 5 9 9 10. Then it said that count of 5 is 3. Then after that we have erased 5, and it has erased all the occurrences of 5. So count of 5 now is 0. So that is it for multiset. Now we'll look at unordered set. Okay, so now let us look at unordered set. We'll just include the header file for that. Unordered set. Now we can use unordered set. Let's say we will declare one unordered set of integers named us. We will just insert some values in it. Let's say 98, 55, 102, 2, 5, 89, 89 again, 65 again, 45 again. So we can see we have not inserted in sorted manner, as well as we have inserted the duplicates. Now we'll just look at the output. We can see You can see that it is stored in completely random manner, not in sorted order, and also it has removed all the duplicates. So the key difference between set and unordered set was set is sorted and unordered set is unsorted, that is in random manner, and you can see it is random manner. Now everything else is closely same to the set in this. Also, in this unordered set, we don't have lower bound and upper bound functions. Mm, I'll just try to show you one, two functions. Like, let's say we will try us.count. We will check if 89 exists in it or not. It should give us, yeah, this should give us output 1. After that, I'll try to, let's say, okay, I'll just show you this function. The rest of the functions you can check for yourself. Yeah, it has given 1 because 89 is present in the this unordered set. So yeah, that is it for this video, guys. I'll see you in the next one.